Okay, guys, in this video, we're going to take a look at directional derivative also, but this time, the direction will not be given using an angle. The direction will be given using a certain vector. Okay, but the idea is the same, and unfortunately, I cannot do a geometric interpretation of this thing because I have three variables here. So we have x, e to the power 8y, and then cosine 7z. The point at which we're interested in finding the directional derivative is 1, 0, 0. And the vector, the direction vector is negative 5I plus 2j minus 4k. Okay. All right. So the first thing we do is find the gradient. And the gradient is just finding partial derivatives. Now here, what I want you to look at is if you're looking at the function that you're trying to find the partial derivative of, you can think of it as a product of two terms, a term that has x and a term that doesn't have x. Actually, here there are two terms, but either one of them doesn't have x. Now they are multiplied, they're not added, because remember when they're added or subtracted, the terms that don't have x will cancel out because derivative of a number is 0. But here, because this is x multiplied by some expression that has y and z, because y and z are considered like numbers, this blue thing is just a number, even though it looks like a complicated number, but it's just a number. What is the derivative of a number x, like 5x? 5, right? So this complicated number x is just going to be that number. So this is going to be e to the 8y. So that does not change. And you do not need product rule, because some people may say, oh, well, I probably need to do product rule because I have a multiplication, right, when I do the derivatives. But the thing is, this blue thing does not have an x in them. If it did, then you would have to use product rule, but it doesn't, okay? Same idea is going to be with fy. The terms that don't have y will stay as they are because they are constants, okay, now, so they don't change. It's like a constant multiple. So this is going to be x, and then cosine 7z is going to stay unchanged. E to the power number y, derivative of that is e to the power the same thing. So you're using chain rule. E to the something is e to the something. But then you have to multiply by the derivative of the something, and derivative of 8y is 8. So that we're going to put over here. Finally, f with respect to z. Again, because you're doing with respect to z and we are multiplying things, x is a number and e to the 8y is a number. Both of them, even though they look like they're complicated, they're not. They're just a number, which we keep. We don't change them. And derivative of cosine is negative sign. So I am going to have a negative. Let me see if I can stick that in here. So this is going to be a negative. So this is going to be sine. It's not going to change. It's still going to be 7z multiplied by the derivative of the 7z, which is 7, right? Because you're using chain rule. So there's your negative 7. Okay, so let's see if we can type all of that. And I am not sure if order matters. Sometimes it might. So kind of customary to put the e first and then the cosine or sine. So also all minuses, put them in the front. All numbers, put them in the front. So let's hope that that's correct. Okay, the next step is to actually plug in the point they give you 1, 0, 0 into the gradient, okay, and you will get a vector. However, because both here y and z are zeros, so if I want to find fx, which of course you can use a calculator, but I'm not going to because I'm going to be able to do this in my head because e to the power 0 is 1 and cosine 0 is also 1. So that's just going to be 1. Okay, the derivative with respect to y at 1, 0, 0. So here it's going to be 8 times x. E to the power 0 is 1. Cosine 0 is also 1. So this is just going to be 8. And finally, the z at 1, 0, 0 will be negative 7. X is 1. And again, e to the power 0 is 1. But sine of 0 is actually 0. So when you multiply all of that, that's just going to give you 0. So you have to, again, use ijk, looks like, right? If you go to vars, it shows you. So this is just going to be I plus aj. And then you could put plus 0k, but I'm not going to do that. Okay, so that's the gradient. So what do we have to do next? Well, we need to deal with the direction vector. And why do we need to deal with it? Because remember how if they gave you an angle, then cosine theta and sine theta already is a unit length, right? Because cosine squared plus sine squared is 1. But if they give you a vector of direction, which is not through an angle, this length, this new vector v, will not be normalized. And it has to be. Because otherwise, if it weren't normalized, you can actually multiply this by any number, and your directional derivative will also be multiplied by that number. So you're going to have infinitely many answers, because every time you multiply by a number, your directional derivative will change, because v will change, right? That doesn't make sense. It should be the same number. So what you need is just show the direction vector that has a unit length. So you need to find the magnitude of the direction vector. If you forget about that, your answer is obviously not going to be correct. So this is going to be, when you find the magnitude, do not include the negatives, because they will go away when you square. There's no point of doing that other than just confusing yourself and making the teacher be mad at you, which you don't want. Okay, so this is going to be 25 plus 4 plus 16. Okay, so it looks like that's 20. So this looks like square root of 45. If you want to, you can simplify that as 3 square root of 5, whatever, but I don't think that's necessary. So here you want to put, again, IJK, so negative 5 divided by the square root. Remember, we are normalizing it, so making it unit length. Or I call it also put a hat on the vector. So the difference between v with the arrow, right, this one, does not have to have unit length. With v with the hat, right, is put a hat on the vector. That one does have a unit length. Of course, 0 divided by square root of 45 is still 0, so you don't have to do anything else there. Okay, it doesn't like me. Oh, sorry, I'm looking at that vector. Ah, see, I'm making a mistake that a lot of times when my students make, I'm like, oh, how could you make that mistake? And I just made it myself. Okay, so here I'm looking at the wrong vector. You're normalizing v, not the gradient. Ooh, oh my God. Okay, so this is going to be, yeah. It's good that I checked my work, otherwise I would have to redo everything. Okay, so now that's correct. Now we do have the v hat, and now we're ready to find their dot product. So dot product is just going to be the x components multiplied, right? And the y components multiplied, and the z components multiplied, and then you just add them up. Well, that one is just 0, so I'm not going to write anything here. So this is going to be negative 5 divided by square root of 45 plus 16 divided by square root of 45. Okay, you do have to simplify here because this looks like the same bottom. But, you know, if you want to put 45 as 5 times 9, so it would be like 3 square root of 5. Fine. Or you can leave it as square root of 45. I think it'll be the same.